about electric shock? That's the fun stuff, right? Our objective is to know the damaging effects of electric shock, or the result of current passing through the body. From Ohm's law, we can see the current depends on the voltage applied and also the electric resistance of the human body. Voltage supplies the push. Resistance opposes the push. Current is the result. Your body has a resistance that ranges from 100 ohms if soaked with salt water to about 500,000 ohms if your skin is very dry. Touch the electrodes of a battery with dry fingers and your resistance to the flow of charge would be about 100,000 ohms. So with that large of a resistance, are we going to get a noticeable current? No, you just say, no, nothing's happening. It's happening. You're just not able to detect it. You would not feel 12 volts, and 24 volts would just be a tingle. Or sweating, 24 volts could be quite uncomfortable. All right, so let's look at the effects of current. We have 0.001 can be felt. 0.005 is painful. 0.01 involuntary muscle spasms. 0.15 loss of muscle control. So that's the muscle control loss happens a lot when you get shocked. Let's say you're working on some kind of electrical device and you're not being safe and you accidentally touch a wire that could potentially have current coming through it if there's a potential difference, which your hand will gladly provide. So if you touch on let's say you grabbed a wire and you got a little shock, the loss of the muscle control will cause you to grip that wire even more because your muscles are tightening. So you can't let go of the wire that's killing you. 0.7, if through the heart, serious disruption, probably fatal if the current lasts for more than a second. 0.1 amps is going to be an instantaneous thing, and 0.2 is there's no surviving. Many people are killed every year from current from common 120 volt electric circuits. Touch a faulty 120 volt light fixture while standing on the ground, and there is a 120 volt pressure between you and the ground. It pushes you down. You get knocked backwards. Soles of your shoes normally provide very large resistance, so the current would probably not be enough to do serious harm. Unless you're standing on a metal ladder and not wearing shoes. If you're standing barefoot in a wet bathtub, the resistance between you and the ground is very small. Your overall resistance is so low that the 120 volt potential difference may produce a harmful current through your body. Drops of water that collect around the on-off switches, like hair dryers, can conduct current to the user. So if you're using your hair dryer in that steamy bathroom, you are endangering yourself. Although distilled water is a good insulator, the ions in ordinary water greatly reduce electric resistance. So what that means is there's charges, this charge that exists in the water naturally. There's also minerals, flakes of iron or calcium that are really good conductors within the water. There's also usually a layer of salt on your skin from sweat. Nasty. Which, when wet, lowers your skin resistance to a few hundred ohms or less. Handling electric devices while taking a bath is extremely dangerous. Handling a wet hair dryer can be like sticking your fingers into a live socket. The poor birds. What about them? They just hang out on the wire. Nothing ever happens to them. You've seen birds on high voltage wires. Every part of the bird's body is at the same high potential as the wire, and it feels no ill effects. For the bird to receive a shock, there has to be a difference in potential between one part of its body and another part of its body. Most of the current will then pass along the path of least electric resistance connecting these 2 points. Suppose you fall from a bridge and manage to grab onto a high voltage power line, halting your fall. If you touch nothing else of different potential, you'll receive no shock, even if the wire is thousands of volts above the ground. So when you see the squirrels hanging from the lines, or the birds hanging out on the lines, it's the only thing they're touching. So there is no difference between them and the wire. And remember, there has to be that potential difference. There has to be the difference for current to flow. Voltage is not what kills you. Remember, voltage is just a push. Current is the result of that push. The current is what will kill you. No charge will flow from one hand to the other because there is no appreciable difference in electric potential between your hands. What about those things that you see, they're fenced in and they say danger, high voltage, that kind of thing? Is that dangerous? Because I just said voltage won't kill you. Yes, it is dangerous, because when you're in that instance, if you don't know where to properly place conductors like yourself, then you could easily create that potential difference and allow for current to flow through you. So the voltage sign is not necessarily deadly, but if there's a potential difference between that really high voltage and yourself, that would be a deadly situation. Ground wires. Mild shocks occur when the surfaces of appliances are at electric potential different than other nearby devices. If you touch surfaces of different potentials, you become a pathway for current. To prevent this, electric appliances are connected to a ground wire. That's that round one, the round piece of the plug, through the third prong of a 3-wire electric plug, that thing. All ground wires and all plugs are connected together through the wiring system in the houses. So all the ground wires connect to each other. The 2 flat prongs are for current carrying double wire. If the live wire accidentally comes in contact with the metal surface of an appliance, the current will be directed to the ground rather than shocking you if you handle it. So it's a safety device. Where does the flow of electricity go if it just goes into that? Somewhere in your house, you have a grounding, this big metal piece that actually goes into the ground. And all of the grounds are connected to each other and then connected to that ground metal bar to direct the current to the ground. That's where the name comes from. One effect of electric shock is to overheat tissues to the body or disrupt normal nerve functions. It can upset the nerve center that controls breathing. Think about this. If the resistance of your body were at 100,000 ohms, what would the current in your body be if you touched the terminals of a 12-volt battery? Pause. Try it. All right, here we go. Using I equals V over R. V, R, very, very small, quite harmless. Here's another one. If your skin were very moist, so your resistance was only 1,000 ohms, and you touched the terminals of a 24-volt battery, how much current do you draw? Pause. Try it. You would draw 0.024 amps, a dangerous amount of current. Concept check. Answer it.